Hello everybody, welcome back to the channel. I haven't uploaded in a while, and this is Cracko298. Today, I'm going over how to mod Minecraft 3DS, and this will go over, in minor detail, how to modify Minecraft 3DS, among other Nintendo 3DS games. This is not a guide for all games by any means, however, it is a guide for relatively getting into the modding community, modding scene, and understanding the basics. So here we go. I've developed a few tools for Minecraft 3DS or MC3DS that allow you to, well, modify the game and source code. You can find these tools at my GitHub at github.com/cracko298. So the first one we are going to be taking a look at is MC3DS lib. You go over here and you download the Python file. Or not the Python file. Blech. Sorry, my bad. You go over here and you download the installer. It'll install or it'll download it depending on if you have Chrome, it might be down here, or if you have Edge, it might be up here, or wherever you have your downloads at. Double click it and it'll run. It'll say gain the latest MClib version, and it'll get all that and it'll install it perfectly. And now what we can do, oh, that was another project I was working on. Alright, so let's do a Python file. This is a very simple MC3DS lib. You import that. Control S to save, and we're just going to save this to my downloads folder. And we're going to call it example. Let's import the OS module 2, sys, and what's another one we can import? Time, because we'll need to import time here in a bit. Sometimes if you're doing image processing, you'll need a pill. So we'll do the pill and we'll import the image library. After we do that, we can start our new thing. So with MC3DS lib, you can look at the documentation, which is here. It's not really documentation at this moment, however, it is documentation nonetheless. So you can extract bytes from a file, you can convert bytes from the file, you can extract colors, you can invert the colors, say green hues, orange hues, blue hues, and red hues to traditional 3DST skins. You can grab metadata from files, you can convert materials to JSON files, you can convert an options.txt from a traditional Windows format, which is UTF-8, to the UTF-16. You can use blang to JSON, which converts the blang or language location formats to JSON, and then you can convert them back, so you can make translation hacks and all that. Can do all this. You can create an R3DST, and you can do a lot more. You can get the 3DST image dimensions, convert images to 3DST, and back from it. So let's get into it. With this tool, all you need to do, we are gonna get the blang file, and we're just gonna set a variable to this, right? So maybe you set var is equal to MC3DS lib, and you would just treat it or do it like you normally would a Python file. You can read up on the documentation even more if you so choose. So let's delete all that. We don't need this file anymore. Don't save. Another few more cool tools are the other tools developed by other mod creators, and in this case I'll go over here. Where is it? Minecraft 3DS, I think it is. Nope. Well, you can also do mass blang conversions as well using tools. But there's another one that can convert as well 3DSTs, but it's a Java one right here by BJT Mastermind. On his GitHub, you would just go over here and download it. Perfect. I'll also go into right now how to start your process of modding and finding things out. And so for this, we'll go over to MC3DS USA, you need to extract this ROM or get it from God Mode 9. You get the extracted ROM FS and you start digging. In this case, we can go to the structures and city, and this is all NBT data, which is readily able to be accessed and modified. What's another one? The 3DS has a font, LOC, credits, commands. We are looking at BJSON. I have this so it automatically opens up into HXD, which is a tool that you will need to disassemble certain parts of machine code and all that and compiled stuff. You can also use Gehidra, which is another which is a decompiler. This is a hex editor that it just basically allows you to see the raw bytes. And resource packs, there's a lot of stuff that we haven't done here yet. So example, skins, if you want to read index files or IDX files. I actually have never seen this file format. Yeah, it's a bunch of garbage. I'm assuming this is probably a here, we'll open up an HXD and I'll show you what I mean, kind of, and then I'll show you what I mean with like a traditional 3DST file and how you can start your own path onto creating them without needing tools. So we're going to take this and we're just going to open this up with HXD. It'll pop up right here. We'll see we have a bunch of data. What you can do to this data, or at least when I first started, is find out what the header information is, if it even has header information. So it could be these bytes right here. That could be it. It could be OX 20 bytes or 32 bytes in length. Could be 16 bytes in length or OX 10. So you should be able to do digging by modifying certain values in here, and you can also do that by just opening up Gehidra and looking at this as well and decompiling in ARM v6, Little Indian. And so yeah, let's get into the 3DS T-skins though, and how I found out and how to format them and how to go over them. And then after I do that, that'll be the end of the video. And so let's go right here. Skins. We're going to do the base skin, and we're going to do a 17 kilobyte one. Right? The dummy and Steve, these are all actually ETC2, and then they are ABGR files. And these files are pretty easy to understand once you get the gist of it. And so you can tell that this thing has a header, and you can tell that the data starts about here because there's really nothing up here. As you can see, there's a whole lot of just stuff. Right? And so what we can do is either use a tool like a 3DST converter or use an already made Ohana 3DS version to basically view these files, which is already made, but that's what I didn't know about that when I first started. And so this is the name of the file. As you can see, it says 3DST there, 3DST there. That's the name of the file. This is the motor version of the file. This is actually the version, my bad. You scroll over and you get about 8 bytes worth of basically nonsense. So this entire thing is just none. It's just telling you the version. And so I believe it's 2 bytes per major, minor, something in patch, right? And so that's what that is. This defines the size or width. This defines the height, and these two are checksums. These 4 bytes right here are checksums, and these 4 bytes right here are checksums. This right here is the MIP value, which allows it to be a greater or less quality image. This doesn't matter because this was done at runtime or when it was converted, and so even if you change this, the data stays the same regardless. And so if you modify it, it won't do anything. And yeah, and so if you go and so this is the name. Now, how did I come up with this information? Well, it's simple, really. So I opened up a tool called Ohana, right? And I went to Tools, BCH Replacer, and I imported these files. Now, I'm going over here to copy this directory. I'll open it up in Ohana 3DS, and I'll which one is this? That's right there. This is the dummy.3dsd. So I'll open this up, and it'll give me a texture, random texture, right? And it's all that random stuff. You know, actually, this is a terrible one to do it on. We'll do it this because there's no data here to begin with, so we'll do it that. We'll close dummy 3DST, and we'll continue with Steve.3DST. All right, and so as you can see, the texture of Steve right here is quite normal, and we can export this just to see it a little bit better. So I'm just gonna name it something random and come back up to it, and we'll take a look. As you can see, it's a little blurry because this is, how do I say it? It's a little blurry because it's 60 pixels by 60 pixels. As you can see, I'm zoomed in quite a bit. Right, and so we can tell that this is the Steve skin, basically. What we are going to do is the hex code of 000000 is black, right? And you can tell certain patterns within these files. So if I come down here, you see how these are all zeros, and then it just magically, the next line, it turns into these. And that means that there's a pattern somewhere. And so if you keep scrolling, so this somehow must be no data whatsoever, right? It's null byte, no bytes, there's no data. And so we can deter that this means that the pixel is off because it's an image. And so we'll scroll back up. And so with process of elimination, if we take this byte and we'll just go ahead and write this to the first of a few of these 4-byte integers. We'll Control S to save it, and we'll reload it up in Ohana. As you can see, there's a black dot up here. It's really hard to show on stream or on video, and so I'm gonna go ahead and save it and show you in person. As you can see, there's a black dot right there. So we know that the file is registering color, and those 00 mean that the pixel is off. ETC2 does not actually officially support this. They made it their own custom encoding version of the ETC2 format and use that instead. And so this was a little bit harder to decipher because of that. It's not a traditional format. And so what we can do now is we can find out which one of these is color, because we know 000000 is color. If you don't, if you didn't know that, you can always search it up. So 000000, and then we can do a hex color, and it'll give us the color of black right here. And that's what we saw in this image. If we pull it up right quick, we can see that this right here, this is black. All right, and so now we need to find out which one of these is color. And so what we can do, which one of these is R, because it doesn't necessarily need to be that this one is red, this one is green, this one is blue. It can be blue, green, red, in which it is, though, of course, or it can be green, red, blue, or it can be green, blue, red, or whatever, really. And so we'll go ahead and we'll do all this. I'll show you guys how to really determine this. So we'll turn this pixel on to a solid color. We're not sure. Again, this would be assuming that you knew all this, but we're going to take this pixel right here and turn it into a full red pixel, or a full red or full solid color without the other two. This will give us a definite what this color is, because this will be the only value that is shown through Ohana. And so we'll go back to open Steve, and we'll see that it's red, kind of red here. You guys might not be able to see it again, so I'll do FF and then I'll replace the file and then reopen it. So the last one is red. As you can see, that's 1 pixel. So this is red, right? So now we can tell that this is red, so we should probably write this down like a notepad or something, so we can say that first byte is alpha, which is a on or off, right? All right, there. First byte is alpha. We can say the 4th byte is red. That just leaves the blue and the green. So we'll now modify this to turn it off, and we'll modify this second one with FF, and we'll reload it up in Ohana because it doesn't automatically reload. Go to Steve, and as you can see, it's blue. It's hard to see on my stream, and so we can just save that back to base, and y'all be able to see that it's green. That means that this byte is green, so we can say 3rd byte is green, and without needing to test that last byte, we can tell you that our 2nd byte is blue, because process of elimination tells us that there's 4 colors, and we already know alpha, red, green, blue were colors or functions or anything like that. And so by process of elimination, if we have other 3, we can deter that that last one is blue or whatever other value it is. And so with this information, we can go ahead and start modifying this file. So maybe we want to turn this off, and we want to turn all these off, but maybe we want to check, right? We know that this byte tells that, hey, these colors are shown, but we don't know if it's fully opaque or if it can be or what. So what we can do instead is just do A0, which is kind of like a cross point. It's more of a 9-0 is a cross between a FF and a 01. And so that's about half, right? It's about half. Let me check. Yeah, about half. Perfect. And so now what we can do is see if this color, this first pixel is white, and we'll go ahead and we'll copy these, and we'll just paste it into the next 4 bytes, next ones, and next ones, just to be able to see it better. We'll reopen the image. And of course, you guys need to know that these are specialized software as well. This isn't a traditional Ohana 3DS. You will be able to get this by just typing in Ohana 3DS Minecraft 3DST, and it should pop right up. It will be a GBA temp thread. All right. And so texture, we can see. Let's export this, and we can see it right there. All right, so base, this won't update it anyway as well, so we'll go over here. And so as we can kind of see, it's kind of opaque. We can kind of see the background, kind of not. So this is really not a good thing for you to go off of, okay? Because just because it's the data is being shown correctly here doesn't mean that the game traditionally renders it like that. And we can test this as well by either opening up Citra Nightly. And let's go ahead and we can take the version 9. We'll open up the, we'll actually dump the ROM FS because we'll need it. Now you can also take your games from GM9 that you decrypt and put them on here, and you can also dump the ROM FS from here. And so we'll go open up the mods location, ROM FS, that vanilla. I think it's resource packs skins. So here, we'll take this. So because it's the same version, we can go skins. We'll do new, then skin packs, open, then we'll do a new one, call it base. And then we'll copy our file that we just modified, Steve, copy it over. And then start the game. So as we will be able to see, if I go over to here, screen layout default, and I scroll up to Steve, you can see that that pixel right there is transparent, right? See that pixel, it's transparent. So this right here, you still can't see through it, as you can see, kind of. And we can take this a step further and make his whole head transparent, and it won't be, per se. This is because, funnily enough, there are certain values that the game just ignores. It's either on or off. It's like a 1 or a 0 or a Boolean true or false. And so we can go ahead. What? Okay, so my old mods still work. But yeah, as you can see, like I have blah 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 whatever. And so this is like the first step into taking new formats, modifying them for your own self, and seeing what you can come up with. And then if you have the knowledge, build scripts, build applications to optimize that. If you guys like this video, make sure to like it. If you didn't, well then don't. See you all in my next video. Bye bye.